So in the first video I mentioned that the vertex could either be the lowest point or the highest point. In this video we're going to learn how to distinguish between the two. So just as a reminder, I'm going to write our quadratic equation right here, just so I can reference back to the variables and the letters. So two things could happen. We've got two different shapes. All right, so we're going to have a shape like this. If A is positive, we'll have one shape. If A is negative, we'll have a different shape. Okay, so if A is positive, the graph will be right side up. All right, so it'll look something like this. Okay, if that's the case, the vertex is the lowest value. Okay, so in that case, if it's the lowest value, it would be the minimum. Okay, so that's if A is positive. If A is positive, it's right side up, so the vertex would be the lowest value. If A was negative, then our parabola would be upside down, something like that. And if our parabola is upside down, then the vertex would be the highest value. Okay, so that's this value right here would be the highest value. So also known as the maximum value. Okay, so two different things that you could find with the vertex, and it all depends on whether A is positive or negative. So again, it opens up like this, and it has a minimum value if A is positive, and it opens down like this, and A has a maximum value if A is negative. Okay, so two different shapes that you could be dealing with. So in this example, we are going to identify whether we have a minimum or a maximum. So this first step is pretty easy. Literally all we're going to do is look at this term, the quadratic term. If the coefficient is positive, then remember we have a minimum. And if our coefficient is negative, then we have a maximum. All right, so 4, of course, is greater than 0, so A is positive. And since A is positive, that means our graph opens up like that. And so when it opens up like that, we're going to have a minimum value. All right, so it seems kind of counterintuitive, like positive seems like it would pair with maximum, but picture what the graph looks like. So if you've got a positive value of A, we actually have a minimum value. Okay, so that's the first step. Again, kind of straightforward. You're just looking at that quadratic term and seeing what sign the coefficient is. So now state the maximum or minimum value of the function. When you are asked to state the maximum or minimum, what that means is find the vertex. Okay, so we're going to find the vertex. So our x-coordinate of the vertex, remember that formula from the previous video, it's negative b over 2a. So we can grab that right off of our equation here. So negative b, so b is this number right here, that's a negative 24. So a negative 24 becomes positive over 2 times a, which is 4. So we've got 24 over 8, which reduces down to 3. So that's not the minimum or maximum value. The minimum or maximum value would be the y value. So we find the x value, but then we need to plug it in to find the y value. Because when they say minimum or maximum value, they are talking about the height, which goes with y. So now that we know that the minimum value is going to occur when x equals 3, we plug the 3 in to our function. So remember, this is our function notation that tells us use this function f and plug in 3. So 4, I'm going to replace this x with a 3, minus 24, replace this x with a 3, plus 11. So order of operations, 3 squared is 9, 9 times 4 is 36, minus 24 times 3 is 72, and then plus 11. Okay, so 36 minus 72 is negative 36. If we add 11, we get negative 25. So that's the value that we're looking for. That will be the very lowest y value that your graph will hit. Okay, then state the domain and range of the function. Okay, so domain is all reals. Every single parabola, every single time, the domain will be all reals. That will never, ever, ever change. Okay, so that's always the domain for parabolas. The range, if we kind of do like a little sketch, we don't know what the graph is going to look like at all, but the one thing we do know is that it opens up like that, and we know that this y value is negative 25. So if it opens up and the lowest y value is negative 25, that means the y values that get hit are everything from negative 25 on up. So our range would be all y values that are greater than or equal to negative 25. So anytime you're dealing with a minimum value, your range will be greater than or equal to that minimum value. So vice versa for a maximum value. If you're dealing with a max, it will be everything less than or equal to. Okay, so do a quick little note for that. So if you have a max, your range would be y is less than or equal to whatever that maximum value is. All right. So example 4, the last one that we're going to look at here, this is a bit of a story problem. It says a souvenir shop sells about 200 coffee mugs for $6 each. For every 50-cent increase, he'll sell about 10 fewer coffee mugs. So we're kind of testing out like a supply and demand thing. So how much should the owner charge to maximize the monthly income? So we're kind of going off what we were doing here. We're trying to find the maximum value of the parabola, but since it's a story problem, we have to create our equation first. Okay, so our variable that we're going to define, x is equal to the number of price increases. Now, does he increase the price once? Does he increase the price 6 times? So we're going to set that up. So in words, looks something like this. So the total, like the revenue, the total cost is going to be the number of mugs times the price per mug. Okay, so kind of putting that out in words first. Okay, so the number of mugs times the price per mug. Okay, so let's use income as a capital I, so that's going to be our variable. The number of mugs. Okay, so here's how that is going to look. Selling 200 mugs, that's kind of the initial amount. This is like their standard that they're starting with. And then he thinks he'll sell 10 fewer coffee mugs for every increase. So it's going to be 200 minus 10 mugs per increase. So remember, x is the number of increases. So we start with that. And then times the price per mug. It starts at $6, and he's increasing the price by 50 cents. So plus 50 cents per price increase. Okay, so that's our income. Now, hopefully you guys love to FOIL, because we're going to FOIL this out real quick. So this equals 200 times 6 gives us 1,200. Outside 200 times 0.5x, remember this is half, so half of 200 would be 100x. Inside, negative 10x times 6 would be negative 60x. And then last would be negative 10 times positive 0.5. So negative 10, half of that would be negative 5. And then there's an x squared. Sorry, I was squeezing that in. Okay, so let's simplify that. Combine up like terms, and I'm going to write it in the order that we're used to. So the quadratic term will go first. When I combine these up, my linear term will be a positive 40x, and then my constant term is 1,200. Okay, so one thing you could think about, if there are no price increases, he's making $1,200, which makes sense. 200 mugs at $6 each. If there's no price increase, he'd make $1,200. But it says, how much should he charge? So we're trying to solve for x. So we are going to find the maximum value for this. So we're going to do it the same way we did up here. We're going to find the vertex and figure out what that value is. So x equals negative b over 2a. That's the x value. Equals, and we set negative b, which is the number in front of x, so that's 40, over 2 times a, which is negative 5. So negative 40 over negative 10, negative over negative reduces to a positive 4. So the first question is, how much should the owner charge? So we're going to start with that. So 4 price increases means $6 is the original cost, plus 4 price increases of 50 cents. So 4 increases of 50 cents would go up $2. So that means he should charge $8. Oops, that's off the page. He should charge $8. All right, so that answers part A. What is the maximum monthly income the owner can expect to make? So just like here, we took the value of the vertex and plugged it in to get the y value, we're going to take 8 and plug it into this income equation. Okay, so the income, if they charge $8, and we are just going to replace the x's in the equation with 8's. Equals. Okay, so 8 squared is 64. 64 times negative 5 would be negative 320. Plus 40 times 8 would be 320. Oops, I must be doing something wrong here. Okay, 64 times negative 5. Am I doing something wrong? That's right. And that's right. Okay, so then plus 1,200. Okay, so these end up canceling out, and we are going to end up with 1,200. Oh, okay, I see what I did. I'm sorry. We are going to scratch this. You should not be plugging in 8. We should be plugging in 4, because that's the x value that will maximize. I greatly apologize for that. So that's I of 4. This should make more sense. Okay, negative 5 times 4 squared plus 40 times 4 plus 1,200. Let's try that again. Okay, I'm sorry. So this 4 squared would be 16. 16 times negative 5 would be negative 80. Plus 40 times 4 would be 160. And then plus 120. Okay, so negative 80 plus 160 would be 80. And then tack that on. So 1,280. Okay, so not going to be much more than we thought he could have made to begin with. So that would be our final answer after 4 price increases.